What do you enjoy about science?
Well, I love to do things practically, so I'm actually in the lab with my co-workers quite a lot. We are doing exciting projects in the fume hood, and my philosophy is that you cannot make any new discoveries behind the office desk. You make them in the fume hood. You make them by observing, of course, having good ideas and trying them out and seeing where it goes, and then follow the trails that are most promising in your research.
Where does your passion for science come from?
I should acknowledge my parents very much for that, because my parents, as a young boy, they took us around in the Scandinavian woods, in Sweden and in Denmark, and we were collecting everything from butterflies to lichens to flowers to rocks, everything that you could possibly collect. We made collections from that, and we made displays of it. So that was my first inspiration. And also, I was very, very lucky because my grandparents have a farm in Bornholm where I was shipped off to every single opportunity they had. So I was there, and I was out in the morning at 8 and in at 9 o'clock in the evening. So I had a whole day of nature and, being in the fields, in the forest, in the beaches and so on. That was really, really nice as a child. And one of the things I remember very clearly is I was lying in my grandfather's barley field, and you have this roof of the barley on top, and then you have a microscopic world underneath with poppy flowers and all sorts of wheat, but also a lot of insects. So there was these big green grasshoppers, I remember, and I remember clearly that I was already then thinking about, how does this evolve? Where does it come from? So that was my sort of first kind of inspiration for thinking about nature and chemistry.
How did it feel to get the Nobel Prize call?
When I received the message from Stockholm on the Nobel Prize, that was really cool. First, I thought it's probably a prank played by my students, because I've tried that before. But I could very, very quickly hear that this was not a prank and this was serious. And I talked with 3 committee members, and they told me about it, and it was very, very exciting. Then I had to wait for an hour, and that was kind of tough, to wait for an hour not telling anyone. Even my wife I couldn't call. And after that, I heard the announcement, and as soon as I opened my office door, there was like hundreds of people in the corridor outside, 50 people in the corridor outside, all cheering, and that was very, very pleasant experience.
What happened after the call?
No, so we had a lot of congratulations and cheering and so on, and then there was a press conference, and after that, in a period of 2 hours, the head of department arranged a big get-together down in our big hall. And that was really a good experience. There was like 300 people or so, all cheering over this. Because in Denmark, it's not such a usual thing to get a Nobel Prize. It's actually 25 years since we last got a Nobel Prize, and it wasn't even at Copenhagen University. So they really thought this was a perfect opportunity to celebrate.
In Denmark, your prize has been very celebrated. Some are comparing you to a rock star. How has that been?
I wouldn't say a rock star, but a science star, yes. And I actually go to young people to inspire them. So we have something called the Science Club in Denmark, and they engage with 4th and 5th grade students to try to inspire them to get into science. And I think that's a very, very good initiative, and I think we should actually expand dramatically on that. Young people have the ability to store images much better than we have as grown-ups. If you remember back and reflect on your childhood, you will see it as images. And I think that we should actually take an opportunity there and try to use our modern capacity of doing animations and so on, and make the young people understand not by rules and not by calculations of quantitative measures, but rather by visualization of the chemistry universe. I mean, we cannot see the chemistry with our eyes. It's so small. So if we can animate it and make it, the property of these young people, maybe they get a completely different kind of interest in science. And since chemistry is everything, as I say, I think it's important that they learn about it. Not only for doing new inventions, but also for general public opinion and for making the right political decisions and so on.
What advice would you give to a student or young researcher?
Well, I usually tend to say that ambition of becoming something is not the right driver if you are interested in science. If you're interested in science, it should be the science itself that drives you, so that you should be interested in the actual problem that you are handling. That should be what really excites you. And the only way that that can excite you is by you knowing about some of the parts that are happening, and you're curious about the things you don't know.
How important is sustainability for you?
Sustainability, in my opinion, for all of us is our future. There is no future without sustainability. So I think that chemistry can offer an important impact on sustainability. I have some examples that I usually take out, but I think everything can be seen in at least having a certain amount of chemistry content in them. So, for example, our windmills are made with wings that are glass fiber. And glass fiber is not the healthiest once it starts to wither away. We will have all these fibers everywhere. That's not nice. So if we can make new materials there, solar energy, can we make something that is cheap to make and that we can put on the roofs of buildings and so on, that everybody can afford? There's a lot of things that chemistry can do for us. Can we make concretes that are not water compatible, so they won't be wet inside and degrade? There's a lot of things that you can think of in chemistry.
What are the key implications of your research?
Well, click chemistry is a chemistry all by itself. It's green, so it's completely atom economy. There's no waste. All the parts that go into the reaction also exist in the product. It can be carried out in water. Because of this copper catalysis, the copper acts like a template for gathering the reactant, so you can do it at very, very, very low concentrations and still get quantitative reactions because of the big difference in energy between the starting materials and the products. So it doesn't go back, essentially. That's what characterizes it. And it also that it can be carried out anywhere, anytime, selectively. In the presence, even inside cells, as you will hear from Caroline. The copper catalyzed click chemistry is used everywhere. It's like sort of a crown jewel because it's used in material sciences, it's used in surface modifications, it's used in all sorts of medicinal chemistry today. So I think that it has changed what we can do. It's not only that it has made things more easy to do, it's simply changed conceptually what can we do. We can take functions that are separate functions in molecules and put them together into one molecule so we get a molecular robot, essentially.
How do you cope with failure?
I'm very fortunate to have an ability to forget about failures. And that's, so I just go on. I usually have several things going on at the same time and just go with the things that seems to show success. And that's probably my way out of that, I guess.
What qualities do you need to be a successful scientist?
Well, of course, you need you need a lot of will. So you need a lot of endurance in what you want to do and why you want to do it. You need to be able to think. That's, of course, clear. But it's also that you pursue goals that are associated directly with what you want to solve, what kind of problem you want to deal with. And I usually dream. A lot of the things I do, I dream about them at night, or before I fall asleep, I think through all these issues and problems that are there. And I think, you know, if you leave your job at 4 and go home and forget everything until you meet next day at 9, that's not how you become a good scientist. That's one thing. The other thing is, if you have ambition driving, I mean, if it's not the actual problem that is driving your curiosity, but more, I have to do this because I want to achieve to become this professor, or write this paper in science, or become a Nobel laureate in the end. That's not going to take you anywhere, in my opinion. It's a curiosity and the engagement in the problem that makes a good scientist.
How important has collaboration been to your success?
I mean, in science in general, collaboration is very important because none of us can know everything what you need to know today to do great science. But I would also say that the idea doesn't come as a collective group. The idea that leads to something very new can happen at a bus stop, or, as I said, before you fall asleep at night, or in the bathtub. You know, it's not something that is made by will. It's made because it just happens in your mind. And only one person can have that mind going for them. So it is usually always, even if it's a collaboration that ends up being a collaboration, it starts out somewhere.
How can we encourage more diversity in science?
Yeah, so I'm a little bit against quotations, but that is because I think, in the same way that I think that curiosity is a driver, I think that it's really about everybody as a person in science. And everybody has that opportunity today. I think we should definitely encourage our young, and I'm sure I can see that already now in the universities, that if we talk gender equality, I think that is coming up almost by itself, because the boys cannot follow the girls any longer. They are just going ahead like that, in our university at least. And then you have also equality across different cultures. I think that's important, and I think that we should try to, in particular in a small country like Denmark, to invite the best brains from abroad to come and study and get their education in Denmark, maybe stay if they want to, and help developing our technologies in the local area. And I think that could be the same for everywhere.
How important is music in your life?
It's always been important. So I have with me here a guest, Henrik Schütte, who is a fantastic artist, and so he's a painter, and he is also playing music, and I played music with him for many, many years. And then I have started playing samba, as you said, with a samba band, in around the same time as the click invention. We were in Brazil, and we played in the area of Salvador de Bahia. So we were actually making our life by traveling around with bus and playing for local communities. And we got, shelter and food, and we traveled to the next spot and so on. And that was a really, really big experience for me, a great experience, and very good friends. So recently I gave a lecture at the Royal Danish Society of Science and Letters, and they had actually invited this band for a fantastic celebration. And it was very good to see them again, because I haven't played with them for the last 18 years since I got my son. And then I play in a rock band. On Mondays we usually practice. We're not going out playing very much, but we like very much to play cover music.
Do you think music has been important to your scientific career as well?
I think that music is a very, very good way to train the associative thoughts in your mind. So you very quickly, in particular if you're improvising, so I usually put on some African music and play guitar with it. And you very quickly have to modulate your mind in this when you're doing improvisations. So I think that's the same with science. You should be able to quickly make the associations between different understandings, different subjects, different technologies, and so on.
What environments help with creativity?
I think we should get rid of the way that we are actually funding today. So funding is by what I said before. You sit behind your desk and you invent what you should do the next 5 years, and you send in your application. And then half a year or a year later, you're actually getting the money. So now it's 6 years of planning ahead. And I think that's completely wrong, because you should be able to, without notice, change the track of your research to follow the most exciting things that you observe in the lab. This is really my my idea about what is wrong with the current way of funding research. So if we could fund instead based on what you have achieved the last 3 years, for example, in terms of peer-reviewed publications, maybe even teaching and so on, fund based on that, and then allow the researcher to decide what is important and what is not important. The people who are in the evaluation panels, I deeply respect the efforts they are doing. But honestly, I don't think they can be experts in all the things that they are actually evaluating. And I often see, funding where I cannot help thinking, why is that? Why was that funded and not something else?
Can you tell us about the object that you're donating to the Nobel Prize Museum?
Yes. This object here is a Teflon block. This is the first multiple column peptide synthesizer in the world, I guess. It was made in 1987 in the garage of my neighbor. So he had a workshop and I could drill the holes and do everything and put it together. So that I did, and it can be used for synthesis of 20 different peptides. But we also used it for combinatorial synthesis. So this is used for some of the first combinatorial synthesis. And we have here a paper that actually describes its use here for combinatorial synthesis of millions of compounds. So this is a great thing. Yeah, you want it up? So this is a great thing. You can see, no. Yeah. So you can see this is the same as you have here. And this is a procedure to make millions of compounds. This is a procedure to make millions of compounds. And we improved it dramatically. So here is a modern version of this machine. Where we can, in 1 week, we can synthesize 2 million compounds. So this is really cool. And this is actually what led up to the click chemistry, because in the 90s, we were all looking for quantitative chemical transformations. In order to do these millions of compounds, we need clean reactions. And click reactions is essentially a clean reaction that only happens like that, right? So we were looking for it, and we were very lucky to find it. Yes, so this is actually, but that's what I see, if you have a problem, go for it. Don't think that this is for the workshop, or this is for a physicist, or this is for somebody with optics. Go for it yourself. That is my advice to the young people who want to do research.